Good day, Doctor. We are from TeamNexGen. My name is Tai Yu, metric number 159152. Today, our team is going to present the software testing project for our system, CarMate. Have you ever forgotten your scheduled car maintenance service, only to realize it is too late, still relying on that faded service sticker on your dashboard? Or maybe you have faced a flat tire or urgent issue not knowing how to respond quickly. And when it comes to monthly expenses, lost track again, right? Those surprise costs can wreck your budget and planning. We get it. Managing your vehicle shouldn't be this hard. That's why we built CarMate, your proactive car care assistant, a web-based, mobile responsive solution that automates service reminders, simplifies car care, and helps you to stay on top of expenses, so you never miss a checkup and drive worry-free. All in one app right at your fingertips. CarMate has 4 modules, which are User Account Management, AI Chatbot, Reminder System, and Expense Tracking.
My name is Dickson Tan Di Sheng, battery number 157835. Now I'm going to talk about the white box testing on the CarMate application. So, white box testing is a type of software testing that analyzes the internal structures of the software, such as the data and code structures, internal design, and the working of the software rather than just the functionality of the application. In this project, we employ 2 white box testing techniques, which are control flow-based testing and API testing. Control flow-based testing is a type of testing that uses a program's control flow as a model to evaluate the test coverage in terms of statement, decision, and path coverage. For API testing, it involves verifying the internal logic, code paths, and data handling of the system API to ensure it functions correctly and securely from the inside out. In this presentation, we will conduct a control flow-based testing on the Add New Vehicle function, which is a method that allows users to register a new vehicle in the system. From the pseudocode, we can see that the function consists of 3 if statements. Our testing strategy is structured around control flow testing techniques, starting with statement coverage, then decision coverage, and finally path coverage. Our first coverage metric is statement coverage. This technique ensures that every executable statement in the method is executed at least once during testing. To achieve 100% statement coverage for a new vehicle function, we created 4 test cases. This allows us to verify that all code paths are being triggered at least once, ensuring that no lines of code are left untested. Next, we focus on decision coverage, which is also known as branch coverage. This type of testing ensures that every possible true and false scenarios within the code is executed at least once. For the Add New Vehicle method, we again require 4 test cases to fully cover all the decision points. This gives us confidence that every conditional path behaves correctly under both outcomes. Last but not least, we also apply path coverage to our method. This is the most comprehensive form of control flow testing as it covers all possible paths through the method. Despite its complexity, we determined that 4 test cases were sufficient to achieve 100% path coverage for the Add New Vehicle method. This ensures that all combinations of paths were executed and validated.
My name is Yeo Ying Sheng, metric number 157627. The results of our control flow testing show that the internal logic of the system functions as expected across all coverage types. For statement coverage, every line of code in the Add New Vehicle method is successfully executed at least once. Among the 4 test paths, there is 1 successful case and 3 distinct error conditions, each with different messages. This ensures that all parts of the method are triggered correctly. And with all 4 tests marked as pass, we can confirm that both the core logic and all validation checks are thoroughly exercised. Similarly, for decision coverage, all possible outcomes of the conditional statements within the Add New Vehicle method are tested. The 4 test paths representing different decision branches in the code are marked with pass status to verify that every decision point in the method is evaluated correctly. This confirms that the decision-making logic of the method functions correctly under all tested conditions. Path coverage, on the other hand, identifies 4 distinct paths throughout the control flow. For example, complete and valid inputs, incomplete inputs, invalid VIN length, and non-numeric mileage. Each path results in a different outcome or validation response, confirming that the test actually thoroughly exercises the method's logic under various scenarios. Notably, All paths result in a pass status, indicating that the system responds appropriately with either successful creation or context-specific error messages. This highlights not only the robustness of the method's input validation logic, but also the completeness of the control flow testing in ensuring software reliability and correctness under both typical and edge case inputs.
We also conducted API testing using Postman to test the functionality and performance of endpoints connecting to the back-end server. In this example, we focus on vehicle management features. Here's what we have tested: creating a new vehicle profile, retrieving details by vehicle ID and user ID, updating existing vehicle profiles, and deleting them when no longer needed. Each of these was tested using the relevant HTTP methods post, get, patch, and delete, and the responses all passed, returning the expected status codes like 201 created, 200 OK, and 204 no content. For example, in the create vehicle test, we send a post request to the vehicle's endpoint, and the image shown is the Postman scripts written for this method. And for the result, we got a clean 201 created response, confirming it worked as expected and passed all the test scripts.
We will now explore our black box testing approach, which evaluates the system externally without knowing its internal structure. So as shown, black box testing involves providing test case inputs to the application and verifying the outputs. With zero knowledge of the code, we focus on functionality, ensuring the system meets users' needs. This method is critical for validating features like service reminders, aligning with our goal to enhance car maintenance management as outlined in the test plan. Next, let's look at our black box testing techniques. We've used equivalence partitioning, state transition testing, and use case testing. Equivalence partitioning divides inputs into valid and invalid classes to test boundaries conditions efficiently. State transition testing tracks system behavior changes like reminder creation states, and use case testing ensures end-to-end functionality which covers all user interactions. So these techniques detailed in our test plan ensure comprehensive coverage of CarMate's features such as user authentication, expense tracking, enhancing reliabilities for car owners. Here is an example of equivalence partitioning for the car maintenance service reminders creation feature. We've defined test conditions like reminder date and description length with coverage for valid and invalid inputs across different cases. So for instance, a reminder date before today triggers a specific check for future dates, while a valid date like 28th of June supports scheduling with ease. So this approach leverages our test plan's focus on boundary testing to ensure a robust performance and user-friendly design for CarMate users, while being able to adapt to real-world maintenance needs. Now let's discuss state transition testing for the same reminders feature. So this technique tests how the system moves between states, like from ready to display reminder based on users' actions with care. So as shown, invalid inputs return to the input field for correction, while valid inputs proceed to the next stage smoothly. So this approach is part of our test strategy, which ensures CarMate adapts to user inputs dynamically, which supports our mission to improve maintenance tracking and reflecting the latest system design enhancements as of today. Finally, use case testing validates complete user flows with attention to detail. For reminders creation, we tested scenarios like valid and invalid inputs across multiple steps. So as seen, valid inputs initiate a new reminder process efficiently, while invalid inputs prompt a review process for accuracy. So this allows CarMates to deliver a seamless experience from account setup to reminder management, which fulfills our goal of a reliable car care assistant as outlined in our test plan and meeting users' expectations as of now. Now, let's review the test results for equivalence partitioning. We've tested conditions like reminder date and description length with outcomes recorded carefully. So the system displays correct messages such as reminder date must be greater for invalid dates and allows valid entries without issues. So all test cases show success with no failures, which confirms the system meets our criteria. Next, let's examine the test results for state transition testing. We've verified transitions from input validation to reminder creation with invalid inputs looping back correctly. The system handles these states well, displaying type of service is required for errors and creating reminders successfully. All results indicate success with no errors, aligning with our test strategy and enhancing CarMate's dynamic response to user actions. Finally, let's look at the test results for use case testing. We've tested scenarios with valid and invalid inputs for reminders creation thoroughly. So the system adds reminders with valid data and blocks invalid entries with clear errors consistently. All test cases show success meeting our functional requirements, and this ensures CarMate provides a seamless user experience supporting our goal of a dependable car care assistant.
Next, let's talk about the testing tools. In web development, one of the most essential tools is the web browser, like Google Chrome or Microsoft Edge. These browsers come equipped with powerful developer tools that help us to debug and optimize the application. We can inspect the console for errors, monitor network activity, analyze performance, and even track memory usage. These features are invaluable when diagnosing why something isn't work as expected on the website. Postman is a useful testing tool for API testing. It allows us to stimulate and validate how data flows across endpoints, using methods like post, get, patch, and delete to make the testing even more efficient. We write automated test scripts in Postman. These scripts validate things like response codes, content structure, and error handling, helping us catch issues early and deliver a more reliable system. Now I'm going to demo how we run our API test scripts in Postman for the Post Vehicles endpoint, which is used to create a new vehicle profile. First, we trigger the request and we expect to receive a 201 created response. This confirms that the vehicle was successfully created in the system. Our test script checks several important things. First is the status code is exactly 201. This tells us the request was processed correctly and a new resource was created. We check that the response is in JSON format. We validate the return vehicle object contains all the required fields. We also verify the VIN length is within the valid range and the mileage must be a number. Lastly, we ensure that no sensitive fields like password are exposed in the response, helping us maintain security best practices. Now, once everything is set up, we click send. The response comes back with a 201 created status, and as you can see, all the 6 test scripts pass.
With that said, not all components pass in the first round of testing. One notable failure occurs during the profile update process. Even when valid inputs like a username and phone number are entered, the system returns an error and fails to update the information. Upon investigation, we discovered that the issue is due to the absence of proper input validation logic within that section of the code. So, as a corrective action, we added appropriate checks and feedback mechanism to ensure valid values are actually accepted. And once this fix is implemented, the test case passes and hence the functionality performs as intended. Through this process, our team gains hands-on experience in applying software testing techniques and working collaboratively during debugging and validation processes. We find that maximizing CarMate's potential requires both black box and white box testing. White box testing helps us analyze the internal code using control flow techniques like statement, decision, and path coverage, while tools like Postman streamline API testing without repeated redeployment. Black box methods such as equivalence partitioning, state transition, and use case testing help us assess a system from the user's perspective. And by combining these methods with clear documentation, it makes our testing process more efficient, structured, and of course effective. That is all from us. Thank you so much.